Okay, we're going to now look at arrays. This is for AS and A2. This is part 1. We're going to look at a simple linear array. What's the great benefit of an array? Well, once again, it's actually the impact of how we code. If we had to have a variable for each of these strings, it would be pointless. We might have dim t-rex as string, and then we can say equals Tyrannosaurus. Okay, so we could have that sort of situation there, and we could have a little variable for each string element in the array. Pointless. So an array allows us to store a list, and that is essentially what an array is. It's a list, and there are two types of arrays. There is linear or one-dimensional and two-dimensional, or a table. So if I were to have a table listing the T-Rex, and then next to it, listing the dinosaur, and then next to it listing what sort of historical or prehistorical era it falls into, so T-Rex, Jurassic, or whatever it is, you can see in your mind a table developing, and that is a two-dimensional array. So when you hear two-dimensional array, think table. But for this particular video snippet, we're just going to look at a single array. And the first thing to understand about arrays is that each item in the list or element in the list is given an index number. In VB, it starts at 0. 0, 1, 2, 3, 4. And what I've done here is I've just said list all of the dinosaurs in my array. So for each dinosaur, okay, it's a string. In the dinosaurs, please just simply write it out in our console and write the name dinosaur. Okay, so dim dinosaur as string, listed. The parenthesis indicates straight away that each one of these items or elements they called in the array gets a number, an index. Okay, and that just simply lists it. Over here, don't worry about that, that's just a space. But this is the important one. I want you to see that at index 0, we're going to get dinosaur 0, which is that one there, Tyrannosaurus. Let's hit compile. So index 0, Tyrannosaurus. Index 4, what is that going to be? Index 4, let's have a look. Number 4. 0, 1, 2, 3, 4. Should be Deinonychus, whatever the case is. Sorry, it says index 0 equals Deinonychus because I didn't change the text here. So index 4, let's have a look at that again. Deinonychus, there it is, number 4. And so on and so forth. So very simple program to show you what index number is which string item in our array. Okay, and this is linear or one-dimensional. We're going to look at examples of what we can do in an array. All arrays should be able to do the following: initialize, insert, find, delete or remove, and get the length of the elements in the list. And of course, output the entire list. And I'll show you 3 or 4 programs that can do this so that you can have a demonstration of what it means by dynamic structure. An array is dynamic because you can initialize it, i.e. set up a new list. You can insert elements into a list. You can find an element within the list. You can remove an element, and you can find out how many elements there are, and you can print or output the entire list. Let's look at how to initialize an array. Here we've got dim int data as integer, and this is simply a list of numbers, and this is how we declare or initialize our array. Here's a string array. Pete, Jack, Mary, Jane, John, dim names as string. And then we can also declare an object. These are various elements that are not necessarily integers or strings, they are simply objects. We know that this is a string because of the quote marks, but here we have an alphanumeric, here we have another alphanumeric, and here we have a concatenation of alpha and alpha. So these are just called objects because they are so disparate in their data type. Well, let's look at inserting an element into an array as well. But before we do that, let's go back up to initialization. So, right, initializing an array. Oh, sorry, there we go. Right, so we've got our list of dinosaurs, and we've said the variable name is a dinosaur, and the variable is equal to this array. So once again, it's instead of saying dim T-Rex as Tyrannosaurus, dim MR as Amargasaurus, and so on and so forth. It's an efficient way of holding data. Once again, impact on memory and efficiency of coding especially. Alright, now we can add another 3. So let's go back to, and that's initialization. Now we can insert or add elements to an array. And let's go back to how we do that. So add Gorgonsaurus, Alexaurus, and Arthinkisaurus. Let's add those to the array. Okay, we've listed our array, and by the way, going back to what was at index number 4, it's Deinonychus. So if I just press enter, we've got Gorgonsaurus, Alexaurus, and Arthinkisaurus added to our array. You say, hang on a minute, this is a separate little block in our module. Correct. All we now need to do is concatenate, and there's a little bit more if you actually want to insert it into the original linear array that occurred up here. There's a little bit more than that, but that's just to show you how to simply add an array. This one has actually been declared as a new array list, so it's not really inserting it into this, but I'm just showing you the basic code to add. So I'm going to close that off. I'm better save that for later, and let's move on to finding an element in an array. And the example I've got an array string with 3 areas, Reading, Woking and Woolwich, and I've got the starting postcodes for some of those areas, RG7, RG40, RG41. And by entering in the part postcode, I will find the corresponding area. Okay, and this is very interesting. Found, exhausted as Boolean. We've got to have, once again, because it's a do until, we've got to have a way of exiting. Now in the past, you'll remember we've created counts, and if count equals less than 0, then we can exit the program. That's one way to do it. But this is an interesting way where we have this variable called exhausted, which is a true or false. And if we've gone through the whole list and we haven't found a match for the part postcode, we exit the program, which is great. And we've got a kind of count going with this index. But that's really feeding off the position in the array. So that's how it's looping. Let's have a look at that example away. Here it is. We've got a count of 3. That's actually more than what we've got here, because it's 0, 1, 2. But that 3 is very important because it will help us to exit later. We can remove that altogether. But anyway, let's move on. Okay. Whoop! That wasn't meant to happen. Let's just see if we can run that again. Invalid cast exception. Alright, I'm just going to hold there and fix this program. Right, silly mistake. Declared text as an integer. That's all string. Right, so I'm going to try RG40. RG40, press enter. City not found. Typical, because when we're dealing with elements, that has to be exact. So it's capital letter. And it should have found, RG40 should have found Wokingham. Let's see what's going on here. City not found, console read line. Oh, that's because it just read without telling me what's what. Beg your pardon. And another silly mistake. Okay, so RG40 is in position 1. So actually it's finding position 1 in our names array. Should be Wokingham. Okay, so if we found it, we're going to return the postcode index and we're going to equal the zip code index. Big mistake there. It's not zip code, it's postcode. And whoops. And another mistake. And the silliest of mistakes, because I started using an American piece of code, so apologies for that. Let's just head on. This is my little entry. So this is my entry when we read it from the console. So I'm going to enter RG40, press return, and it's working. Great. Exit out of that. Yep. So what was that about? That was about finding. Okay, let's close that down. And let's move on. That's finding an element in an array. That's a linear search technique to search for an array by looking at the index positioning. Right, let's move on. And I said move on, there we go. Removing an element. Right, we're going to first initialize a new array. The quick brown fox jumped over the lazy dog. And once we've initialized that new array, we're then going to remove it. So let's find out what's happening with this one. Is this the one? Yep, I had it there. Let's have a look. Yep. Alright, so the quick brown fox jumped over the lazy dog. We're not only going to just create an array here, we're going to remove an item, we're going to remove the word lazy, and then we're going to deliver that array after the word lazy has been removed. Then we're going to remove something at position 5. So we're removing not just an element by referring to its actual text name in our list, its text string, sorry, in our list. We're actually going to remove an element with index as well. That little at means we look for whatever is in position 5. Then we're going to look at all the values after removing the element at index 5, and we're going to print screen. We're going to output that, and then we're going to look at all those elements again, and then we're going to do this here. This is just a very simple subroutine that is going to show us what we've got in our list after that, after the whole thing's been done. So that's the full array. That's removing the word lazy. The quick brown fox jumped over the dog, removing element at 5. 0, 1, 2, 3, 4, 5. So jumped the dog. Over is being removed. After removing 3 elements starting at index 4, because we said from 5 onwards. 0, 1, 2, 3, 4. So over the lazy dog, or over the dog has been, or yeah, the dog has been removed. So the quick brown fox. And now I want you to do, I've commented it out here, but I've got a new, I want you to look at a new bit of code here, and that's how to count the elements in our array. So this is called the length of our array, and that's the code there. So I'm going to add dog and cat, and I'm going to count that. Let's just have a look. Let's have a look at this last bit of code. Let's run that first of all. By the way, system.collections is what you need to import in order to use this keyword count. In 2013, I believe you do not need to import that, because the word count is now fully reserved 2010 onwards. Right, here we go. You entered 3 items. It's counted how many items we added. Let's just close that and say and fox. Let's add and fox. So we're going to say dog, comma, cat and fox. We'll just put an and we'll put dog, cat, monkey, lizard, fox. 1, 2, 3, 4, 5. It should be 5. And it's counted the items, all with this reserved word, my list, which is the list you've initiated. Remember that word initiate, and you've counted those items in your array. So, quick recap. Let's go back to our PowerPoint show right to the beginning, because every array you should be able to initialize it, insert an element, find an element, delete an element. They usually say item. In America, we say element, but anyway, item or element. Get the length of the list. In other words, the number of elements in your list, and of course, print out or output that entire list. and that's why an array is dynamic.